Hello and welcome to this video on dependency confusion. In it I'm going to explain what dependency confusion is, and I'm going to give an example of exploiting it using Node and NPM. To do this, I've set up a small company with a little bit of source code. They have a logger module that's stored in private logger, and they have an app that uses it. And they're publishing their logger internally through Vidacchio as a registry. As we can see, the logger's published in here. There's a couple of versions been published, and we'll come to this later. It has no links, and the module's name is widgetshop/logger. So widgetshop, the organization name, and they've chosen that internally, and then module's called logger. If we have a look at the source code, look at the logger first. Very simple. We've got a package file, and what this does, it defines the package. Got widget shop and the logger name, and the source is the index.js. If we cat the index file, 3 exports, info, error and warning, and all it does is just print whatever you've set to screen with a bit of extra information. Something that will be useful later, something we need to notice, is this version says local at the start of all the messages. If we have a look at our application, we have package file, which says it depends on widget shop logger. So that's saying we need to import the logger module. We're importing major version 1, and then because the carry starts, we're doing any minor version and any patch version. So as long as the version that's published starts with a 1, we're fine. And if we're looking here on the versions, it's there, we're okay. The other thing we've got is this npmrc file. If we have a look in there, what that's doing is telling npm to use our local registry. So it's going to use the company's registry rather than npm.js or any other external ones. So again, that's we'll come back to that shortly as to why and how the vulnerability happens. So let's have a go at setting all this up and making it work. If we have a look, npm list, we've got unmet dependencies at the moment. So let's install the dependencies. What this does is it goes away, looks at the package file list, and it installs the package. So it's installed 102, which is the latest version from here. And that matches what we've asked for there. And if we try to run the app, it's run, application started. As we can see, we've got the local message here. So it's using the local version of the logger. Now, reason for this vulnerability and how this comes about is because our widget shop are doing all this internally. What they've forgotten to do is to register the widget shop organization out with npm.js, which is the main repo. So our attacker is going to be able to use that to get their malicious version of the package installed instead of the local one. So we'll see how to do that. So if we go to second terminal, second window, what we've got here is the npm main site, and if we have a look, we want to check whether the organization widget shop exists, and as it says, it doesn't. So the widget shop organization, even though it exists locally in here for the company, and we've got it, they haven't registered it online with npm, and this is what the attacker is going to take advantage of. So very simple, they're going to create their own, or they're going to create their version of widget shop. And we say create. Let's call it give it an email address. Oh, we can skip that for now, it says. There we go. Widget shop was created. So we now have the widget shop organization registered on npm.js. Very simple to do. You don't need to prove it. It's not like certificates where you have to prove ownership of a domain name or anything like that. As long as that doesn't exist, you can register it. Refresh that, and there we go. That's now ours. The attacker owns the widget shop organization. You might be thinking, well, how does the attacker know that they're using, that the victim is using the widget shop organization name internally? Well, if you've ever received pen test reports, you've probably at some point had a finding that's got that's titles like verbose error messages or similar. Looking through those error messages, that's where you quite often see nice big dumps of stack traces or just error messages that say error in and then package names and similar. So if Widget Shop has built this app, they've published it as part of a web application, or they've put out a third-party app, or they put out a desktop app, something like that, that's got verbose errors, then that's the kind of way that this thing can be leaked. You can also look at if they've published sample code anywhere, or stuff like developers have asked questions on Stack Overflow and they've dumped snippets of their internal source code out. They might not realise it, but by revealing just something simple, such as their package file. So, I've got this package file, it's not working properly, what have I done wrong? And they've revealed a widget shop name. Or, what's wrong with this application? Something's going wrong with it, I don't know, I can't get it to compile, can't get it to build. And again, it's leaked. The attackers go through this kind of stuff online, they find these organisations' names, they check whether they exist, and if they don't, it's very easy to register, as we've just seen. So we've got this, let's say, uplinks, there's nothing there. What Vidakio does is it kind of acts as a proxy to upstream to npm.js. So as well as handling your local ones, it will go and look upstream and say, does this package exist upstream? If so, it will pull a copy down and it will override your local copy. And that's what we're going to do. So at the moment, we're on version 102. Our attacker has their widget shop registered, and they've created their own version of the logger. We'll look at the package file, name widget shop logger, which is the same as we've got in here. So the name's the same. Go back over there. And what we've done is we've put a really high version number on it. And the way the package management system works is if it sees a higher version, it will pull it down and install it. So by going 19999, we've kept the major version, but we've pushed the minor version and the patch number to very high. So this should override whatever version they're using internally. Again, if this is leaked and it does happen that they're using 299.99, this might be seen in source code examples and we can just push higher. The rest of this we don't need to worry about for now. This is just to keep npm happy. So we've got that. We've also got our index, which is pretty much the same as in the original code, except here we've got malicious rather than local. So this was I was saying before, this is how we're going to tell that the attacker's version has been installed. And so to publish it, we do npm publish, and we're saying the access is public, and that should upload it to npm, publish it to the registry, and make it public with version 199. So if we come back over here, we have a look what packages we have. It sometimes takes a minute. There we go. We've published a logger, and this is our version. So as simple as that, we've registered an organization and we've put our own malicious version of the logger package on it. We come back over here and we have a look, and this sometimes takes a little while to refresh, but this will pick it up. So what we can do in our vulnerable app, we're currently on version 1.02. As all developers and admins are told regularly to do by security people, we run an update. We're already up to date. So this can sometimes take a little while. There we go. It's picked up a new package. So this isn't one that's been published internally. This is our malicious one. If we do a list, we will see logger 19999. And there we go. The malicious logger has now been used instead. We go back over here, we have a look, we refresh this. Versions 19999, and we now have an uplink to npm.js, which will take us off here to the custom one published by the attacker. If this was internal though, and code's being updated all the time, dev comes in, runs the update, sees a package has changed, they're not likely to think much about it. It's what happens in a development environment. They run their app. It's now pulled down latest version of the it's pulled down the latest version of the logger, but it's not their internal latest version, it's the attacker's latest version, and the attacker now has code running on the developer's machine. And the same thing can happen if you've got a build environment, does an overnight build, that pulls down the attacker's version of the module, and that then has the attacker's version built into it. So as you can see, it was a very simple process for the attacker. All they needed to do is in npm register the organization. So they registered widget shop, didn't have to prove anything, uploaded their Trojan logger, and that was it. Just sat back and waited for the victim to run an update. Victim got the new package, and there we go. We've got code, the attacker's code being built into the victim's project. The ways to defend yourself against this, the main one is whatever organization name you're using internally, get it registered out on the main site. Even if you don't put anything in it, by registering it, you're stopping anybody else from registering it. Other thing you can do, Vidacchio allows you to say no uplinks, so it will be a purely internal repo. That will help if you are never planning to publish anything online, but if something happens, your dev builds and for some reason they're pointing online rather than to your local version, they can still pull things down. So that's a line of defense, but it's not the perfect line of defense. Registering your name in the npm ecosystem will stop the attacker from being able to override it. So hope you enjoyed that. I built all this as part of training for one of my clients. If this is something you're interested in, if you think it would help your organization, get in touch. I do all sorts of web app training and various other bits of security work. So please get in touch and we can work something out. And see you next time for the next video.